Hey you all, I'm going to pick up where I just left off. So hopefully you've calculated the measure of association for our study comparing position on a motorcycle to chance of head injury. And we're going to look at what result you should have got and then look at why it's a little more complicated than that. So first of all, let me go away so I'm off in the corner here. There we go. Okay, so here we go. Here's your data. It was a case control study. We had head injuries, people who's got an injury that wasn't to the head. The exposed group was a passenger. The unexposed group were the drivers. Because it's a case control study, you have to use the odds ratio. You can't use relative risk for case controls. Your calculation, it's this funny diagonal divided by the diagonal, and you get an odds ratio of 0.94. That's very close to 1. So it says there's very little association between position and head injury. Being the passenger as opposed to being the driver looks like it's very slightly associated with a lower odds, essentially a lower chance of head injuries. Okay, that's nice. We could calculate a confidence interval if we wanted using a confidence interval calculator. You'd expect it to be pretty small because this is a really big study. Sounds like we're done, right? Well, not so fast. I have a question for you. Some people wear helmets when they ride a moped and others don't. So let's think about two different sides of this. Who is more likely to be wearing a helmet, the driver or the passenger? And what is the effect of wearing a helmet? And these are an important pair of questions to ask. I'm actually going to start with the second one first. What's the effect of wearing a helmet? You would think, you would hope a helmet would protect against head injuries, right? Well, from the same study, here's the data. We have the people who got head injuries, the people who didn't. And remember in this data, they also knew whether they were wearing helmets or not. So we're going to treat no helmet as being the exposed and helmet as being the unexposed. So take a look at this data, and just like you've done before, calculate the odds ratio and explain your result on the class Google form. So pause this and go do that. Okay, welcome back. Here are the results that I got. I got an odds ratio of 3.91. Now that is huge. Really not that surprising. It says not wearing a helmet, like our ding dong in the picture here, is associated with a much higher risk of head injury. So we have this new factor now. Instead of just position on the motorcycle, we also have this idea of helmets. So let's think about the other side, the exposure. Is there a difference, do you think, between helmet use for riders and passengers? And the thought here is that often, between drivers and passengers, excuse me, is that often the driver's got a helmet, but the driver is giving a ride to some friend and might not have a second helmet for their passenger. So indeed, that's what the data shows. If you go look at the control group, at the people that didn't get head injuries, so kind of our basic type of people, you find that 61.1% of the passengers were not wearing helmets, but only 37.6% of the drivers were not wearing helmets. So there's this really strong association. Drivers are much more likely than passengers to be wearing helmets, and we know that helmets are strongly associated with the outcome. People who are not wearing helmets are much more likely to have head injuries. So how should that affect our interpretation of the results? We knew that passengers and drivers had a similar rate of head injuries. I'm just repeating what I said. Passengers are much less likely to wear a helmet. Helmets are associated with a lower rate of head injuries. So let's imagine that we're only looking at people who are wearing helmets. In that case, which do you think would be the safer position, the passenger or the driver? I want you to think about that for a few minutes and explain your thoughts in the Google form. Okay, welcome back. Helmet use is what we call a confounding factor. It is something that is associated with the exposure. Again, repeating myself, drivers are more likely to wear helmets than passengers, and simultaneously associated with the outcome. people who do not wear helmets are more likely to get head injuries than those who do. So the fact that it looked like our passengers were at about the same risk of head injuries as drivers, even though our passengers had a much lower rate of helmet use, means that if we were only looking at people who were wearing helmets, the passengers must do a lot better than the drivers. Otherwise, in our whole group, the passengers would see a higher rate of head injuries because they have this ridiculously low chance of wearing a helmet. So if we think about this confounding factor of helmet use, it suggests that being a passenger should be more protective than we thought it was before we considered this confounding factor of the helmet. Now, we're going to talk about confounding factors in general more, but first, I'd just like to dig into this data and check that that's really what's going on. So we do what's called stratifying by the confounding factor. That is, we take our data and we split all these people up into two groups, the group that was wearing helmets and the group that was not wearing helmets. And in each group, we calculate the odds ratio. So we can know the odds ratio, that is the effect of wearing helmets. No, excuse me. We can find the odds ratio, that is to say, the association between being a passenger and getting a head injury among people who are wearing helmets. And separately, we can calculate the odds ratio, the association between being a passenger and having a head injury among the group of people that are not wearing helmets. So I want you now to pause this again and calculate these two separate odds ratios for each group and try to interpret what you see. Again, pause, take a moment, and go do that. Okay, so let's look at what you get when you do those calculations. Here are the odds ratios. For people who were wearing helmets, everybody who had a helmet on, whether a driver or a passenger, you get an odds ratio of having a head injury based on whether you were the passenger or the driver of 0.72. That's quite a bit smaller than the odds ratio before we stratified. That's a pretty significant link. It really makes it look like being a passenger is protective when you only look at helmet wearers. Similarly, when you look at all the doofuses who weren't wearing helmets, some of them drivers, some of them passengers, in that group, you get, in this case, actually a strikingly similar odds ratio of 0.71. So that says among people who were not wearing helmets, moped passengers are less likely, significantly less likely, to get head injuries than moped drivers. And since those two odds ratios in this case are so similar, we can say, look, being a passenger clearly is protective. Once you've taken helmet use into account, you would get an odds ratio of about 0.7. This is called stratifying by the confounding factor. We said, look, there's this issue, helmet use. We're just going to split my group up into the helmet wearers and the non-helmet wearers and calculate my two odds ratios separately. It's particularly clean in this case that you get about the same odds ratio for the two different groups. That's really nice and often won't always happen. But this is the one idea of a way we can think about a confounding factor and deal with it. I'm just going to wrap this all up with this summary slide, which pretty much says what I've already said. Our crude odds ratio was pretty close to 1. So when we look at all of these people just as one group, it looks like there's very little protection effect of being the passenger. Now, in this group, either they had both people wearing helmets and no people wearing helmets. I actually could find very few slides that were separate. Here was one of them, very few clip art images. When we stratify, when we just look at this group and we just look at this group, then we get this significantly smaller odds ratio. Once you consider helmet wearing, then being a passenger is clearly protective. Thank you. When we move on, we're going to talk more generally in the next slide about this idea of a confounding factor, kind of more about what it means to be a confounding factor, what types of studies can deal with confounding factors better than others, and in general, how we think about them. Bye. Oh, I have to stop the